Let's take some moment to observe this limit. How do we evaluate? Can we use direct substitution rule? Well, let's see. By replacing the variable x with 0, and we end up with this thing. And you may see that this fraction inside the parenthesis is undefined because the denominator is 0, so the limit does not exist. By using the direct substitution rule directly this time. But we can use the squeeze theorem. And according to the definition of squeeze theorem, the inequality is these three functions. And this middle function is this combination of functions. And according to this combination of functions, we want to figure out the inequalities. I mean the boundaries for them. And then according to the boundary, we can find these two functions. But it's much more challenging if we use this combination of functions to find the boundary. But why don't we just split them into different parts? Let's say radical x, and then e to the power of x, and then the sine function. And then from these three functions, which one is much more easier to find the boundary? And the answer is this trig function. Whenever you see the trig function, use it because the boundary is simply -1 and 1. So let me graph this function. Here's 1 and here's -1. That's the boundary for the trig function. And to graph, let's say sine x, graph this function, looks like that. But you may wonder, like, this is a sine x. What about 2 over x, right? Is the boundary will be different? No. Even though we change the elements inside the parentheses, but the boundary is still 1 and -1. So just use this boundary. -1 less than sine 2 over x, and then less than 1. Since we have this boundary right now, why don't we just transform this middle function and make it looks like this original one? And to observe, we have e to the power of a sine function. So we can apply the exponent function to this inequality. So e to the power of -1 less than e to the power of this sine function, and then less than e to the power of 1. Now, what we're missing is this radical function. So we just simply times this radical function. So it will be radical x, and then this middle function, then this last one. Now, since we successfully transform this middle function, and it looks like the original one, and we have already found this two function by using the squeeze theorem. If the limit of these two functions are equal to a specific value, then we can say that this middle limit will equal to that value as well. So limit of this function as x approaches 0 from the right hand side. You might wonder, why do we use this one side limit, right, from this right hand side? The answer is, since we have the function, we have this radical function, the elements, or the x, must greater than or equals 0. It cannot be negative, right? If it's negative, it will be undefined for this function. So let's say here's a 0, and here are some multiple negative values approaches 0, but they are negative, right, from the left-hand side. So the only option for us is this value from the right-hand side. They are positive, so that's why we use this one-set limit from this right-hand side to put this plot sign here. And then use the direct substitution rule. Replace x, so radical 0 is still 0, and then 0 times this exponential function is still 0 as well. And then for this second one, e to the power of 1 is still 0 as well. So they both equal to 0. We can conclude that the limit of this middle function is still 0 as well. So therefore, the limit of this middle function equals 0 by using the squeeze theorem.